Hi everyone again. So now we're going to solve an in-class problem. This is an addition to what we solved, and it is going to be very similar to example number 29. And this would be the practice that you would do in class. So please take your time and try to do it your own, and then check the solution. So the question is. A small puck is initially stationary on an icy surface. The puck has a large firecracker inside of it. The firecracker is ignited, causing the puck to split into 3 unequal pieces. Video cameras record one piece whose size is 1/6 of the original puck, moving along the positive y-axis at a speed of 30 meters per second. A second piece that is 1/3 of the original puck in size is observed to move along the negative x-axis at a speed of 15 meters per second. Unfortunately, the third piece was not captured by the camera, and xy plane is on the surface of the eye. So just like we did in the example 29, we are looking at the top view, and the surface is xy plane. That means z direction is out of the page, and negative z is into the page. So first thing is, similar to example 29 in the workbook, practice drawing the top view of the puck, so detailed figure, before and after explosion. So you should have 2 figures. And you need to label masses, velocities. If you know the relative masses, show it that way. And if you know the velocities, anything that you should show that, including the directions. And again, if we did this in the class, we would check your answer, but now I want you to kind of pause it here, do the first part, and then check the solution as well. Okay, now I'm going to start the solution. And again, this is for part A, so that's really just the drawing the figure. So we have, before the explosion, we have one piece, and let's call that a puck, and P for puck. And again, that's the xy plane, so we are showing that, and the mass of the puck is mp. We don't know what it is. It's okay, but we are showing that so that we can relate that to the other pieces. And initial velocity right before was at rest, so it's 0. You can either show that, or there's no vectors assigned, there's no question mark, so that means it's at rest. But again, you can also say that VP is 0, okay, in any direction, so it's as a vector. And on the right side, we have what happened after the explosion. And you can see that there are 3 pieces. First piece is moving along the y direction, and that is 1/6 of the mass. So we are writing the masses. So the original puck was mp. This new piece is 1/6. Okay. Second piece has the mass of the original one as 1/3. But 1/3 is also 2/6, right? So that's what we have here. And we just made the denominators the same just to see how the mass was shared better. And that one's velocity is negative x direction, so it is negative direction, opposite to the positive x given here. And the third one, we don't know the velocity, so we just put a question mark, but we can calculate the mass. So you have 2/6 and 1/6 already. That makes 3/6, which means 1/2. So one pieces 1 and 2 makes up the half of the original mass, and the third one is gonna be the other half. So this is how we figure this mass out. Okay, when you add up all those masses, it should give you the total mass. And again, we show the masses, we show the directions, the magnitudes of the velocities as well. We show our x and y directions, and we labeled the pieces in terms of the masses and such. So this is the complete figure. Next, we are going to list what forces act in the x direction, in the y direction, and in the z direction. So this is the figure, and if you think about any forces on the xy plane, on this plane, there are no forces, right? Only the force is that explosion, but that is internal, so you don't show that on the free body diagram because only the external forces are shown. And these three pieces makes up the system, so you do not show the explosion force. Other ones are normal force and the weight force, and we assume that it's frictionless. But normal force is going to be out of the page and weight force is into the page, so they are along the z direction. And there are no forces along x or y. That's good because that means sum of fx, sum of fy are 0, so we can now, as part C, apply Newton's second law in momentum form to the x direction and determine the x component of the velocity for piece 3. And after that, we will do the same thing for y direction, and after that, we will just put things together and find the speed of the third piece and the direction.